In our previous session of vertical asymptotes, we learned that the vertical asymptote is kind of like a barrier or a limit that stops the graph because the graph is undefined at those values. Now, horizontal asymptotes are a little different. Horizontal asymptotes are really more like a guide to the end behavior of the domain. And so horizontal asymptotes have less restrictions, I guess, as a way to put it, meaning that the graph can and will at times pass over the horizontal asymptote. And so this is quite a little bit different than what you have with vertical asymptotes, where it absolutely cannot touch or intercept the vertical asymptote. Now, with horizontal asymptotes, we are only going to have one at the most. Whereas vertical asymptotes, you could have multiple asymptotes. And so there's lots of differences here with horizontal asymptotes. Now, it would be wise for you to kind of read through all of the information in these notes referring to the asymptotes. Now here we have an example about finding horizontal asymptotes, and you can see this is a rather lengthy explanation, and of course I would recommend that you actually read through this. Now you can see we've used a big T-chart here to find the values of this and come up with the actual graph. And so you can see in this graph here that we actually do have a horizontal asymptote at y equals to 0, but we also have an x-intercept at 2. And so you can tell that there will be x-intercepts even when the x-axis is acting as a horizontal asymptote. And the great explanation about this problem is you can see that the x squared value in the denominator has this pull on the graph to kind of hug along the x-axis, and that's kind of gives us our information as to how we'll know what the horizontal asymptote is. So reading through this explanation on your own time and getting a better thorough understanding of this would be a good idea. Now, the information here leads us to kind of come up with a set number of rules, if you will, that help guide our understanding of horizontal asymptotes. And so you can see in this key concept summary, we basically have 3 basic rules that we can determine. Now, if we use m as the degree of the numerator and n as the degree of the denominator, we can basically look at the degree values of both the numerators and denominators and determine if we have a horizontal asymptote and where it's going to be located. And you can see through these rules, if our larger polynomial function is on bottom, then we know that the horizontal asymptote is y equals to 0, which is the x-axis. If our larger polynomial function is on top, on the numerator, then we're not going to have a horizontal asymptote. And then lastly, if they are the same, then whatever the ratio or the fraction that is created between the a and the b values of the polynomials is going to give us our horizontal asymptote. So we'll use these 3 rules to help us find the horizontal asymptotes. So let's take a look at sample problem number 3. Okay, so the first thing we need to look at if we want to determine the horizontal asymptotes are the degree of the function in the denominator and the numerator. So we can see we have 2x and x minus 3. Both of these are linear first degree polynomials. So we can simply say that the m degree is equal to the n degree, which means that we're looking for the ratio of a over b. And what that means is we want the leading coefficient of each of these set up as a ratio. And so the leading coefficient of the numerator is 2. The leading coefficient of the denominator is 1. So we can say y equals to 2. And y equals to 2 is going to be our horizontal asymptote for this particular problem. Lastly, it says, are there any x-intercepts? And of course you could plug in a 0 to figure that out. Also, a quick look at the graph shows us that there is an x-intercept right there at 0. And so either way that you came up with that would be acceptable. Okay, so if we move on to B, the next thing we see is that our degree value in the numerator is less than our degree value in the denominator, so we can say our m is less than n in this case, and that's always an easy thing to figure out because when our degree in the denominator is larger, it's pulling it back to the x-axis. So y equals to 0, which is our x-axis, is our horizontal asymptote. So that was a pretty straightforward one. And a quick glance at the graph shows us that at 2, 0, we intersect the x-axis. And of course, this is a very interesting graph because you can see that the end behavior is guided by the x-axis, and that's our horizontal asymptote. But this middle portion, it has 2 vertical asymptotes, and our middle portion actually does cross the x-axis, giving us an x-intercept. Okay, so let's take a look at the last one here, last example. For this one, we can see that the value of the degree in the numerator is greater than that of the numerator. And so this is going to tell us that we have no horizontal asymptotes in this case. And so again, a quick look at the graph of the function will allow us to see that it has no horizontal asymptotes and if there are any x-intercepts. And a quick glance here at the graph, you can see that there is not a horizontal asymptote. However, we have what's called an oblique or slant asymptote, and that's going to be beyond the scope of this particular lesson. You'll get into that in pre-calculus. But we do have an x-intercept. You can see here at 0, 0, where we're crossing the x-axis. And so this is a unique type of rational function that you will learn in a lot more detail next year.